right, so here are a couple important considerations when you're looking at a geometry example. So there's some relationships you can assume to be true from a diagram that has no marks or measures. Okay, so some things you can just look at a picture and you can assume, okay, that's this is what's going on. And then there's some other things that you cannot assume. All right, and so this is a page to maybe pause and write down your notes, because this is kind of a source of some common mistakes from students in the past, not in the future though. You all will master these things, right? So you can conclude just from looking at a diagram or an image that angles are adjacent, right? So if you see that they share a side and a vertex, you can assume or conclude that they're adjacent, right? The same thing with adjacent and supplementary. You can assume a linear pair, right? So if you see that, if you see something like this, you can assume, okay, then these two angles here, angle 1 and angle 2, would add up to 180, right? It would be supplementary. Okay, and then angles are vertical angles. Whenever you see two intersecting lines, you can assume that angle 1 and angle 3 are a vertical pair and they're congruent, right? And you can assume the same thing about angle 2 and angle 4. They're a vertical pair and they're congruent. Okay, so those are things you can see just from looking at the picture. So you cannot conclude the following. So, all right, so you cannot conclude the following from an unmarked figures. Angles or symbols are congruent. Okay, so you can see two angles that look exactly the same, right? But you can't assume they're congruent unless you see the marks here, right? Okay, so if you don't have the marks, you cannot assume that they're congruent. You cannot assume that an angle is a right angle. Okay, so you can see one that looks like a right angle. It looks just perfectly right, perfectly 90 degrees. But unless you see that indicator there, then you can't assume. You cannot assume that it's a right angle. All right. The same thing with complementary angles, right? So if you see this figure here, and you see that, first of all, we don't know that this is a right angle to begin with, and so we can't assume those are complementary. Or if you see two that are kind of in space and they look like if you put them together they'd form a right angle, you can't assume that they're going to be complementary unless you see some kind of indicators, right? If they tell you, oh yeah, this is 30 and this one's 60, or whatever the case is. Okay. All right. So anyway, so be careful with the assumptions that you make when you're looking at geometrical figures, right? A lot of times on standardized tests, they'll say image is not drawn to scale or things like that, to kind of close that loophole. But just make sure that you go off of given information. All right, so here we have a couple diagrams. So let's see what conclusions we can make. So if we look at the one here, so what I can conclude here, I can conclude that angle 3 and 4 are supplementary, right? They make a linear pair. I can see that they're adjacent. I can see that angle 1 and 2 are adjacent. I can see that 2 and 3 are adjacent, 1 and 5, etc. Right, 5 and 4. So I can see a lot of adjacent angles there. I can see a couple vertical pairs. 3 and 5 are vertical pairs. Angle 3 and angle 5. Angle 4 and the sum of angle 1 and 2, or the full angle there, those would be a vertical pair. I can see that angles 1 and 2 are congruent, right? Those little tick marks, or excuse me, arc marks, denote that they're congruent. So there's a lot that I can see there, but I don't know that, for example, 1 and 4 are complementary, right? I can't see that, even though it looks like they could be. I don't know that angle 3 and 4 are congruent or anything like that. Okay, so just the adjacent vertical pairs, and then we're given the arcs to know that 1 and 2 are congruent. All right, so let's look at this next figure here. see if we can conclude the following. So angle TW, or excuse me, segment TW is congruent to VW. So TW and VW, yep, we can conclude those are congruent because we have the tick marks there, right? All right, what about PW and WQ? They look congruent, PW, WQ, but we don't have any tick marks, so we can't go off of looks alone, right, or appearance alone in that case. So angle TWQ is a right angle. It looks like a right angle, right? TWQ. However, we don't have any information that would give us that as a fact, so we can't assume that. TV bisects PQ. Once again, looks like it, but we would have to know that this is congruent with this, right? And we don't know that for a fact, and so that's not, we're not able to conclude that by the diagram. Angle PWT and angle TWQ, PWT and TWQ are a linear pair. Yeah, we can conclude that, right? Because they form a straight line. They're adjacent and they form a straight line. So yeah, we can conclude that. Angle PWT and TWQ are supplementary. True, right? If they form a linear pair, they're supplementary. PQ bisects TV. So PQ, yeah, it does bisect TV, right? Because it splits it into two equal segments, two congruent segments. So we can conclude that. All right, here's another situation. Similar type of questions. Can we make the following conclusions from the diagram? So angle DAB and angle CDB are congruent. So DAB and CDB. Yeah, we can conclude that, right? We see the arc marks there. So yeah, that we know that they're congruent. All right, number 11, angle ADB and angle CDB are complementary. So complementary, they have to add up to 90 degrees. ADB and CDB. Okay, so let's see, we do know that this is 90 degrees, right? And so this angle, and this is 90 degrees, of course, right? That's given, and then we know that if this is 90, then this has to be 90, right? They form a linear pair. So then we have a triangle here, right? And we know that the sum of the angles of a triangle add up to 180. So if this is 90, then that means that angle A here and angle D here have to add up to 90, right? So that means that angle DAB is complementary with angle ADB, right? So that means that since these two are congruent, that we know that this is complementary with this, right? So that means that they have to be equal, right? So yeah, you actually can conclude that ADB is complementary with CDB. Okay, so it took some work on that one, but they are complementary based on the fact that we know that the angles of a triangle add up to 180, right? So we can actually conclude that. All right, ADB and CDB are congruent. They kind of look congruent, but we can't conclude that, right? So we know that they could be complementary, but not necessarily congruent. But what about ADB and BCD? So ADB and BCD. And yeah, we figured that out before, right? Because we know that this angle ADB is going to be, if we think about a right triangle, it's going to be 180 minus 90, right? This is 90 degrees minus the measure of angle DAB, right? This one. So that's going to be what this measure is, right? And remember that angle DAB is interchangeable with angle, kind of messed up my drawing here, but we know that this angle here, CDB, is congruent with that, right? And so those are interchangeable, and that's what this angle would be, and so therefore we know that they're congruent with each other. All right, let me know if you have any questions. I know that I kind of drew all over that, so it might be hard to see, so you might want to rewind it, or hopefully you have that figure on your paper and you can make sense of all that. But definitely send any questions my way, and we can talk about this a little more in class as well. All right, so our linear pair postulate: if two angles form linear pair, then they are supplementary. So, and we know that, right? If they form a linear pair, that means they make a straight line. Straight line's 180 degrees, so that means those two angles, the pair of angles, have to add up to 180, which makes them supplementary, right? But is the converse true? If two angles are supplementary, then do they form a linear pair? So remember, and we actually haven't learned about conditional statements yet, but the way to prove a conditional false is just by finding one counterexample, one situation where you have two supplementary angles that aren't or that don't form a linear pair. Okay, and so can you think of a situation where two angles don't form a linear pair? Well, remember that supplementary angles do not have to be adjacent, right? So there we go. If I find two supplementary angles, one that's, let's say, 80 and the other one that's 100, and let's say that they're not, that's not right. Let's say that they're not next to each other, they're not adjacent, then they wouldn't form a linear pair, right? So this is not true. So this is false. Okay. And so there's the counterexample, would be two supplementary angles that are non-adjacent.